Going, guys? Why are you leaving? We are going to continue here, not leaving. Well, remember to use the hashtag AdoptingBTC on Twitter, so the guys that are not here will enjoy what we are doing here in the conference. And now we are going to have a more technical stuff right now that is called Splicing with Dusty Daemon. Dusty is a developer for Lightning, and the idea of this track is mainly to talk about technical stuff, to present the ideas that could lead to a more successful adoption through the technologies that are already there. The panel that just happened right now was mainly about Fed means and what is Galoy doing with the stable sats. So now we are going to go deeper into the technical side of Bitcoin with splicing. I don't know if I'm saying that good, but he's almost ready. Are you ready to go? Yes? Okay, I'm going to take some of the chairs and just enjoy the panel. Remember that if you want to use the Wi-Fi, the password is Bitfinex, and also enjoy the conference, share some photos, share some videos on social media, and we are ready to go, Lightning and Splicing.
All right. Hello, thank you for coming. Here to learn about Lightning. Let's go. I'm super excited to be here in El Salvador. Let's get into it. So for those that don't know me, I'm Dusty. I've become a core Lightning developer. It's funny how time flies. It's been like a year and a half of doing that, and I've been doing Bitcoin-related development stuff for like 5 years, and a year and a half ago I decided I was just going to start doing everything I can to contribute to Lightning specifically. Okay, so who here has run a Lightning node? Nice, pretty good numbers. So who here is open to channel with their Lightning node? Great, so you guys are using your channels. For those that don't know, it's just a quick understanding of the explanation of how the Lightning payment network works. So in this illustration, we have these are my little fancy drawings of Lightning nodes. And if you want to move a payment across the network, you hop them across the various nodes. So whoa, it's supposed to be a fancy animation. Don't look, you're seeing the whole slides. Okay, all right, there we go. So if you want to move a payment to anywhere on the network, you go through multiple node hops to get there, which is what this is demonstrating. So what we're going to dive into is the channel. You have to think of Lightning in two ways. There's the aggregate network of all of the channels that make payments possible, but all of the development work is really on individual channels. So the work we do on one channel is ends up scaling to affecting the entire network. Okay, so another important thing about a channel is it has a certain size. There's a certain amount of Bitcoin that is locked in a Lightning channel, and that size specifies how much Bitcoin can move through it. So you can have a big channel, for instance, like this big arrow is showing, or you can have a smaller one. So if you had, say, a large payment you wanted to do, and you wanted to do that same payment we just did, but it's too big for the channel, it's not going to be able to go through. So for larger payments, we need to make the channel bigger to make that happen. But in Lightning, you can't resize channels. So you end up in this fundamental trap where Lightning, you might need to make your channels bigger, but there's no way to do it. Until now. Okay, so enter splicing. Splicing at its core is kind of a simple concept. It's this ability to resize channels. And this is actually a really old idea. I think I first heard about it probably in 2018. But it's one of those things that as developers started working on it, they realized that it was really complex to implement. Like so many things, it seems like, in these cryptography development environments, you have a simple idea and you start getting into it and things get like really complex really fast. And a funny story, actually, about 2 years ago, people were talking about doing, I don't know, loop and atomic swaps and whatever, and I was like on like Clubhouse or Twitter Spaces or something, and I was like, yeah, just use splicing, and they were like, what are you talking about? And I had like read a headline that splicing had been done. And I was like, yeah, this headline says it was done. We've been waiting for it, now it's here. People were looking at me very confused. And turns out what had been done is Rusty Russell and the core lighting team had written the splicing spec. So they had basically written a document saying how you would do splicing after like long hashing out of the security concerns kind of thing. And nobody had actually written any of it. So I was like, okay, well, here's a great thing for me to do for my first project. Perhaps naively. It's been a very big project, but I'm delighted to be working on it. Okay, so we know that lightning splicing gives us the ability to resize channels, but what's become more apparent over time is the ability to resize lightning channels also gives us all of these other crazy benefits that weren't intuitively obvious at first. So the intuitive one is you can increase the size of channels, which if you ever run a lightning node, which a lot of you guys have here, you've probably felt that desire to do so. The most common case is you build a channel out and it starts like getting a lot of traffic on it, and you wish you could add more Bitcoin into that channel to get more routing through, but you can't. Your only options are close it and reopen it, or open more channels, all these kind of awkward little tricks. And the cool thing about splicing is if you want to increase the channel size, you can do it without ever taking the channel down. So there's no downtime with the channel throughout the entire process, which also led to some of the complexity in the spec. But it's cool. There's my animation. Now it's bigger. And now that big payment can go through, as you can see from these fancy animations. Cool. Another weird but awesome side effect of splicing is that you can build a wallet for users, like on your phone, that has one balance that is spendable both in a traditional on-chain payment and also in Lightning. So like one of the user experience challenges these wallet developers have is people have a Bitcoin wallet, like say Chivo for instance, and it's got two things in it. It's got the on-chain balance and the Lightning balance. Now if you're new to Bitcoin, you probably don't know what either of those words mean. So trying to onboard users while explaining how there are these two balances and how to move between them is a big hurdle for new users. But with splicing, what you can do is put all of the funds in Lightning and then do what we call, for on-chain payment, do what we call a splice out. So let's say like I'm a baller and I have like a 1 Bitcoin channel and I want to go like buy this, car for 0.1 Bitcoin. I can leave all those funds on-chain, or on Lightning, excuse me, and then splice out exactly 0.1 Bitcoin. Now the channel will become 0.9 Bitcoin big, it'll shrink, and I can do an outgoing on-chain payment at the same time. So this, I think, is the best place to do this, to store the Bitcoin, is on Lightning, because you have the Bitcoin you have is going to have the most utility and practical uses on Lightning. So it makes sense to store it there, but then pull it out for when you want to do an on-chain payment. And I think this will probably be like the biggest impact of splicing, is like, it'll take years, but as the apps sort of start picking this up, we're going to see, I believe, more and more of these one balance, sort of universal, easier phone apps. Oh, and here's an animation of, you can see a Lightning channel. And there's an arrow there saying on-chain or bust. This is my high-tech graphical skills demonstrating this process. So you can see I've shrunk the channel, and now I'm moving that Bitcoin on-chain. Everyone following? Any questions so far? Hopefully that's simple enough. Okay, another big benefit that is more for like the people running nodes in the network, like you guys doing the actual routing, is moving Bitcoin across channels. So in a single splice transaction, you could take that Bitcoin from, say you made a channel and it's just not doing very well, nobody's using it, it was in the wrong spot, and you have one that's doing a lot. You can use a single splice transaction to both take capacity out of one and then move it straight into the other. And I think this is going to be probably one of the most common use cases of splicing, is people are trying to optimize their routing nodes to get the most efficient stuff going through. And it ends up being the most on-chain efficient way to do this compared to everything else. As I mentioned before, I want to say it again, this is all with no channel downtime, which is really critical if you're running a routing node. Because imagine you have like, the typical story is you're running a Lightning node and you got like, 20 channels. And you have like 2 of them that are doing all of the traffic, maybe 3. And you want to like improve those channels, but you don't want to take them down because they're your most valuable channels. So being able to keep them up while you do these sorts of operations on them ends up being a big deal. Okay, the other crazy benefit that is like, you have to, it's sort of not, it's even less intuitive than the other ones, is when you're doing these splice transactions, they can be batched with other splice transactions, so you can do multiple at the same time. And this starts sounding a lot like a coin join, because it is a lot like a coin join. And the nature of it is it's actually cheaper than doing a regular on-chain payment, the more you merge together, because of the shared transaction bytes. So that's a pretty big deal. So here we have an example where we want to do 3 separate splices. So we're trying to move this Bitcoin from that channel, that channel, and that channel, that channel, that channel, that channel. They can all be merged into a single on-chain transaction, giving you the lowest footprint possible. And another important thing to note is these channel splices don't have to all be your own. Let's say like I got a Lightning channel with Isabel, and she wants to do a splice. Our nodes can automatically talk to each other and do both of our splices merge into a single on-chain transaction. And this coordination is all done over the Lightning Network. So this is like a coin join with no central authority whatever. It's like the most possible decentralized way you could do a coin join. Okay, just to go through some more examples, you could take, I'm taking my ASCII art to the limits here. Yeah, you could take funds from one channel, move it into 3, for example. It's one thing you could do. You could also throw in an on-chain destination, all in one go. And then you could do the same thing the other way, take your Bitcoin from on-chain, move it into 3 channels at the same time, or throw in an off-chain destination. Point is, there's a lot of options with what you can do. So one thing, if you wanted to say, let's just say you only cared about, I think there's a pointer here I can point maybe. Okay, the pointer's not working. So let's just say all you really wanted to do is move this Bitcoin to its destination on-chain. By merging it with a splice, you're making it less clear what you're doing, and you're obscuring stuff, all in a very decentralized way with lower fees overall. Because one of the things with existing coin join providers is almost all of them have a central coordinator that controls them, which is that comes with its own problems, but also they charge heavy fees. And with splicing, because no one controls the network, there are no fees to be paid to any coin join provider. So this ends up actually being a cheaper solution. And down the road, when and if we get things like cross-input signature aggregation, this literally will be the cheapest way to do on-chain payments that exists. So the future's bright for this kind of stuff. I'm going through these examples just to really give you a sense of how many different things you can do. So here we're taking funds from 2 different Lightning channels and moving them into 3 other ones. And then why not throw an on-chain destination in there? Or we could add some funds from on-chain too. So the point is, there's like almost endless ways you can combine these things together, and splicing is really like this foundational building block that allows us to do all kinds of awesome stuff. So that's the non-technical portion of the talk. Thank you for listening. Are there any questions so far? Everybody just follow me 100%? We're all vibing? Okay, so there's like 2 ways we can go because we still got some time. Is I could dive into some of the technical deep stuff, or we could like talk about less technical stuff. Who wants technical stuff? Okay, that's everybody almost. Okay, let's see. I got a bunch of technical stuff here. So one way to think of the base layer on chain is like it's like a Byzantine base layer where it will accomplish certain kinds of, it'll enforce certain rules for you in a very trustless manner. So I like to think of it as a Byzantine base layer. And what Lightning does is you're writing these contracts. We call them channels, but they're really just contracts between 2 peers on the network. And those contracts are enforced by the blockchain. So you write the contract with your peer, but what you do is you write it, but you don't actually publish it. So this is like analogous to, if you think about how many judges there are, I know we're in El Salvador, I don't have the stats are here, but in the US there's about 40,000 judges. And if you think about how many judges that is compared to how many contracts are written and signed in a given year, that number is going to be way off. It's probably in the tens of millions, perhaps hundreds of millions of contracts signed per year, with only 40,000 judges. If you imagine a world where the judges had to be there present and read every contract and watch it being signed, there would be no legal process whatever in the country. So instead, the legal process is split up, where you can sign private contracts on your own, maybe you get a notary, And then only if there's a problem with the contract, you then take it to the court system. And Lightning operates under the same fundamental principle. So with my channel peers, I'm writing these contracts all day long, but I'm not publishing them to the network. And the publishing is the act of enforcing. So I think that's kind of a way to think about Lightning. And when you do a payment through Lightning, what's really happening is we're taking the old contract. We said, okay, maybe I'll use Isabel again. Sorry for calling you out so much. Let's say we have a 1 Bitcoin channel where we have it split. So I have half on my side, half on hers. When I make a payment through Isabel, let's say I'm making a half Bitcoin payment, what we do is we take that old contract saying I have half and she has half, and we just tear it up and we write a new one saying now she has a whole Bitcoin. And this kind of process, this is all doable with Bitcoin scripts, with Bitcoin contracts. So every time we make a payment, we just tear up the old contract, write a new one, we kind of repeat that forever. And this is the mechanism that allows Lightning to both be enforced by the main chain, but be able to scale to high speed, practically infinite sort of transactions. One way to think is contract usurping. You're just constantly writing a new contract to usurp the old one. Okay, so Lightning is the same sort of idea. We're taking the old contract and tearing it up. But the one thing we can't re-sign in Isabel's and I's 1 Bitcoin channel is if we're going to say this channel now has 2 Bitcoin in it, we're doing a splice in, we need to go back to the base layer, to the legal system to approve that 2 Bitcoin actually exists and is here. So this is why for splicing we have to have an on-chain transaction, because the number of Bitcoin is locked at 21 million. Me and Isabel can't just rehypothecate and create 2 out of Bitcoin when there's only 1. So splicing is just another one of these contracts, but that one that we run by the court system in the process of doing it. Okay, how's everyone feeling? Does everyone still want to hear more technical stuff? Okay, got one. Okay, we got some. Okay, I'll just say one more thing, and then we'll finish with the technical things. So in implementing splicing that I've been doing for a while now, the first step to get through it is to realize that the way the Lightning Network operates is all of the nodes are constantly sending messages to each other. So there's a protocol that connect to each other, they say messages like, hey, how are you? I'm doing fine, stuff like that. But also more importantly, they're like, hey, I want to process a payment, or hey, I want to open a channel, or hey, I want to close it, or whatever. So in splicing, we had to add these are some examples there of different types of Lightning things messages that already exist. And with splicing, we want to add in a new one. We add a new message into the protocol that says yo, I want to do a splice. So this is the spec for the splice message, ripped fully from the spec. And that's basically the message. Actually, we just updated it, so this is going to change. But so this is what the doing this Lightning dev works like. Is you're pulling up these specs, you're reading it every word very carefully, and saying, okay, what do these words mean? How do I build the code such that it follows these sorts of rules? So this message is basically yes, yo, hey, partner, I want to start doing a splice with you. And then after that, we get a bunch of more messages. Oh, animations came through? All right. So in this example, this is me and Isabel. We had 1 Bitcoin. Now we're trying to get it to 2. Okay, so in the developing of the splicing message, we realized that when it was spec'd out, I say we, collectively, all of us, we realized that there were all of these weird cases where, let's say we're trying to calculate a splice, but also processing payments at the exact time. There are a lot of edge cases that can form in that kind of scenario that became very absurd very quickly. Because when you're writing the code for Lightning, the effort of the happy path where it just works, that's the easy part. Most of the code is what if things go wrong? What if I'm halfway through a splice, somebody routes a payment, and then they purposely DDoS my computer and then do all these things? We have to write the code to be immune to all of those things. So the complexity got really big. So they entered this new mode called STFU. It stands for Something Fundamental is Underway. Also called quiescence. I can never say that word. I'm sure I'm saying it wrong. So this is a mode that, right before we enter Splice, we go to this STFU mode, and for a brief period, half a second or so, we're just going to pause everything where it is, no new payments coming through, just so we can get through it in a clean process and sort of say, this is the state of the channel, let it be that for this second or so to process these things. And then you want to build a new Lightning contract. So this ends up looking a lot like an initial funding transaction where you're going to put funds in and then you're going to have like change out and stuff. But we're repeating that for splicing. Anyway, I don't want to go through all of this because I feel like half the hands went down when I said technical stuff. Is there anybody with a question? Anybody that's like feeling confused? Who doesn't feel confused? Okay, that was not a lot of hands. Yes. Great question. So is this in Lightning implementation already? It is on my computer. It's currently in the review process. I have it in a pull request to Core Lightning, and it's going through the review process to get into Core Lightning. If all goes well and I work really hard, probably the next release, not this one, so maybe that would be like 2 months or so probably. It'll come out as a developer-only release, and then it'll go through more testing and eventually into the experimental phase, and then eventually it'll start being used in people's wallets. I don't know, what, 6 months, 8 months, 10 months later? It kind of depends. It might seem like a long time, but it's important to do this stuff right, because we're literally programming the future of money. Yeah.
Okay. So yeah, I guess I was just curious. You were saying so like the STFU mode was just like a second or whatever. So even if that splicing transaction to add funds is still like unconfirmed, I'm guessing the Lightning nodes will be able to enforce that eventually, like once it gets confirmed, or
exactly. No, that's a great question. Like where does the STFU mode end? Is it when the transaction gets confirmed or not? It's a great question. And STFU mode is just for building the transaction. And once the transaction is signed, we exit STFU mode, and the splice transaction will get relayed to the blockchain eventually. And we wait for 6 confirmations before we consider it confirmed. Yeah.
We got a new channel ID once the splicing is over, and because it's like a lot of things is that refer to the original channel ID. So if node in the future run a version that doesn't under splicing, can you work with these kind of channels?
Yes. So that's a great question. So the channel ID literally points to the place in the blockchain it's confirmed, and Splice is going to move that to a new spot. So the question is, how will Lightning nodes that don't understand splicing, how will they handle the channel moving like that to a new spot with a new channel ID? And the answer is the old nodes will see it as a channel close and open, but the new ones will realize that it's the same channel just moved. So it ends up being reverse compatible.
Like I mentioned in another talk, is that the path finding algorithm is really like will reward like keep a reputation on the channel ID. So this is more not really increase the size of channel, but replace the existing one.
Yeah, exactly. And it sounds like you're talking about. I should speed this up. So it sounds like you're talking about routing services will give higher score to channels that are up longer, and that they would lose that in splicing, but those nodes should update their policies to count splicing channels as continuing to exist. Okay, I think that's time. Thank you so much. Thanks for coming and listening.